Hello, Honors Geometry, and welcome to our sixth video of the year, the sixth video of this unit. And we are now past factoring. We're now into the second part. So it's factoring and solving quadratics. We're going to start solving quadratics today. We're going to do 2 lessons on solving quadratics, and then we are done with this unit, and we're going to move on to the first unit in geometry, which is the tools of geometry. So like the basic ideas. So let's get right into this idea of solving quadratics. So the first thing that we're going to look at is this question. What is the solution for x plus 6 equals 10? So this goes back to the beginning of algebra when you were talking about solving equations, and you're talking about specifically solving linear equations. Why I know it's linear, and I say linear, is because it's x by itself, or x to the power of 1. When that showed up in algebra, you were like, okay, well, we got to move the 6 to the other side. So we subtract 6, and we get left with x equals 4. Great. There's your answer. Not that difficult. Now what our problems are going to turn into is, instead of having an x, we're going to have some x squareds in it. So how would we solve x squared plus 5 equals 9? That's something new that we're going to have to be able to answer, and it comes down here to this bottom. If the equation has x squared, your goal is to get it by itself and take the square root. So if we get x squared by itself, okay, I need to move the 5 to the other side, so I subtract 5 on both sides. I get x squared to equal 4. Once you get x squared by itself, then we're going to take the square root. Square root of x squared, we've seen it a lot this unit. We know that that's x. Square root of 4, if we put it in our calculator, is 2. Now, this is where it gets interesting. What I'm going to tell you is all quadratics, so all equations that have an x squared, have 2 solutions. Okay, so do all of them have 2 solutions? The answer is yes, they do. So what's going to happen is, when you take the square root, we actually put a plus or minus in front of the square root. So it would have looked like x squared when we had equals 4. Take the square root with a plus or minus in between. And it comes down to the idea of a positive times a positive will be a positive, and a negative times a negative will be a positive. You talk a little bit more about that in Algebra 2. I just want us to get into the habit to know anytime it's x squared, there are 2 solutions. But when you get into Algebra 2, you'll talk about more about why and the concepts and all that behind it. So we're going to solve these following equations where they have x squareds. Okay, we need to get x squared by itself. So on this first problem, to get rid of the 6, we're going to add 6 to both sides. I get x squared equals 16. Once you get x squared by itself, take the square root. Now, when you take the square root, add a plus or minus in the front. Square root of x squared is x equals plus or minus square root of 16. In your calculator, you can do that. We get 4. So my answer is a positive or a negative 4. Okay, and this positive or negative 4 is what would make this equation true. Okay, if I look here at B, I want to get x squared by itself, so I'm going to move the 67, so I'm going to subtract 67 on both sides. I get negative x squared equals a negative 64. If you have a negative in front of your x squared, divide both sides by a negative 1. I get x squared equals 64. X squared by itself, take the square root. In front of the square root of the number, we put a plus or minus. Square root of x squared is x. Plus or minus square root of 64 is 8. Okay, when we look at the last problem, I'm going to move the 13, so I'm going to subtract 13 on both sides. 3x squared equals 27. Then I need to divide by 3, so x squared is by itself. Divided by 3, I get x squared to equal 9. Then I'm going to take the square root of both sides, plus or minus in front of the number. Square root of x squared is x, plus or minus square root of 9 is 3. There's my final answer. We'll look at a couple problems of these in class, and we'll substitute back in to show and see that that is true. So now the question becomes, what happens if we have both an x and an x squared? So what happens if we would combine the linear and the ones that are quadratic that just have the x squared? We need to talk about how we can solve for those. And what we're going to do is there are basically 3 options we're going to walk through. We're going to walk through 2 of them today, and then the third one the next lesson. So we could look at a graph way how to solve them. We could solve these with our factoring that we have been doing. And then the third one is a quadratic formula. Okay, so we're going to talk about graphing and factoring today, quadratic formula next class. So let's start at this, solving it by the first option, which is graphing. When solving this by graphing, you're going to graph the equation, which I will show you, and we'll look at it on Desmos together. We're going to look for what are the solutions for the quadratic. Well, the solutions are once they're on the graph, you are going to find where they cross the x-axis. So where they cross the x-axis, you're going to do x equals, and whatever that x value is, that is your solution. So I'm going to first turn over here, and I have some graphs all ready here. Now, these last two are the same, and I just wanted to mark on one a little bit more than the other. So I have my x-axis, I have my y-axis. Okay, there are 2 points that this graph crosses the x-axis, and that should be true for every quadratic. Every quadratic has 2 solutions, so that means it crosses the axis 2 times. So I'm putting points there where it crosses it. Okay, this one point is 0, 0. That's at the origin. This other point, if I do it x comma y, is -4, 0. Your solutions are going to be x equals, x equals. They are the x values of the point that cross the x-axis. So x equals 0, x equals -4. Okay, I just left this one here so if you needed to reference something what I've marked, it's easier to tell. Okay, if I go up to this one where I only have one of it, okay, I have a point here, I have a point here. Simply, if you don't want to write out the points, there are just numbers on these graphs. This point is above 1, so it's x equals 1. Okay, and this one is at x equals -5. There are my solutions. The graphing is pretty easy. Okay, it's when we get into the next ones that it's a little bit more time consuming, but it's not as difficult either. So let's go down here to this next question. What do you do if the graph is hard to read to get the exact solutions? So what if our graph was difficult? That's where we look and we have 2 options. We can factor, or we could do the, like I said, the quadratic formula. Okay? If your graph is hard to read, these are your 2 options. We're going to talk about factoring today, and I'm going to, once we have factored it, we're going to graph it on Desmos, and we're going to check our answers that way. Because I'm going to show you on Desmos how a feature on there will allow you to exactly see, even if it's not one of these nice ones on the points, exactly see if that's the right answer. So when solving quadratics by factoring, here's my steps. Okay, I want to make sure all my terms are on one side equal to 0. I'm going to factor the quadratic, and then once we have factored it, we're going to set each binomial, which remember our binomials are in parentheses. So set each parentheses and any GCF that has a variable equal to 0, and then we're going to solve for x. Okay, again, just like the last lesson where you're like, hey, that's a lot of steps, I'm not sure what this looks like. The more you practice it, the better it's going to get. And we're going to walk through it here and also in class. So don't think that we're going to quickly get through this and then you're going to be like, I have no idea where I'm at. So here on this first problem, okay, so let's build our graphic organizer together. Okay, when looking at problems that tell you how to factor, remember factor is up on top. When they tell you to factor, the first step in factoring is to always factor out a GCF. Once you have factored out a GCF, remember we branched it off into 3 things, and it was based on counting the number of terms. So if the problem has 2 terms, if it has 3 terms, and we did talk about it if it has 4 terms. Now, if it has 4 terms, remember in class I told you this was Algebra 2. They will introduce 4 terms in Algebra 2. We cover 2 and 3. If it has 2 terms, the only type we have is difference of squares. Okay, we have to check, is it a difference of squares problem? If it is 3 terms, it's either a problem where a equals 1 or a does not equal 1. 3 terms is your trinomial. Okay, we're going to reference this back. So we are. So I'm going to keep it up here off to the side, easy to get. First step, check for a GCF. There is a GCF in this problem. Okay, our GCF is 6x. Okay, I'm going to go through and take out my GCF. 6x of GCF out front. Take your original problem, divide it by that GCF. Oh, I guess I forgot one step. I forgot to tell you, this is already set equal to 0 so we can continue. My bad. Okay, I should have told you that because we're going to have ones down here that are not already there. If it's set equal to 0, that's what allowed me to go right in here to factoring. Okay, now 6x. 6 divided by 6 is 1. I had 2 x's. I took away 1, so I'm still left with 1. Negative 12 divided by 6 is a negative 2. I had 1x. I took away 1, so I'm left with none. Okay, once you take out your GCF, think about what's inside of the parentheses. Inside of the parentheses is 2 terms. So if I look back here, I have GCF, it has 2 terms. Check to see, is this a difference of squares? Well, my answer is no. This is not a difference of squares. Even though there's a minus in between, I can't take the square root of these 2 terms. So if it's not one of that, you're done with your factoring. Okay, I've done all that I can. So now I'm at that step at the bottom where it says set each binomial. So set each thing in parentheses. So x minus 2 equal to 0. And include any GCF that had a variable. My GCF was 6x. That has a variable. That also has to be set equal to 0. X minus 2 equals 0. If I solve that for x, I get x equals a positive 2. If I solve this for 0, I would divide by 6. 0 divided by 6 is 0. There's my 2 solutions. X equals 2 and x equals 0. Now, let's go over here to the graph and see if we get the same thing. Okay, now that we have factored this, an easy way to check solving quadratics by factoring is to turn to your graphing. Graphing is such an important tool with these quadratics, and it's easy to tell whether or not your factoring was right. So, easy way to check it is here with Desmos that we have available to you. Remember, it's in that additional resource folder. Once you're here on Desmos, to get to the graphing part, click on Graphing Calculator. Okay, right here where the number 1 is, I'm going to write down my first equation exactly how it was right at the beginning, which was 6x. Okay, I'm going to hit the up arrow squared. To get out of anything with your exponents, hit the over arrow to the right so it cancels it down. Minus 12x equals 0. Okay, there's my graph. I could zoom out so I could see it. But I'm really concerned with is where does it cross the x-axis. Now, your x-axis is this middle darker line, but the nice thing on Desmos, where it crosses the x-axis, they put on these gray dots that you could hit and they turn to black. Notice, remember back in our graphing, your solutions were the x of those points where they crossed. So it'd be x equals 0, x equals 2. The same thing we got by solving this by factoring. Okay, now that we've looked at the graph, let's move on here to B. So here on B, first thing, it is set equal to 0, so I can go right into my factoring. Okay, a reminder, first thing in factoring, check for a GCF. In this problem, there is no GCF. Okay, there's no numbers that they have in common, and not each term has an X. So now, it has 2 terms. DOS. Is this a difference of squares? Well, there is a minus, and also notice here, if I take the square root of x squared, it's x. Square root of 25 is 5. Since there is a minus in between, and again, it has the square root of both, it is a difference of squares. Square root of the first term, or square root of x squared, goes first. Square root of the second one, or square root of 25 or 5, goes next. One gets a plus, one gets a minus. Once you have factored, set each parentheses equal to 0, as well as if you had a GCF with a variable, set that equal to 0. When I solve these for x, I get x equals 5 and x equals negative 5. There would be my solutions. And again, let's look at the graph here real quickly. Okay, now let's look at B and let's look at that same thing. Remember, just like number 1, write your equation how it was right from the beginning. So x squared minus 25 equals 0. Now if I scroll out, what makes this a quadratic? This one's hard to tell. When we get to one that's easier to tell, I'll show you. But quadratic crosses the x-axis in 2 places, just like that last problem. Look for those gray dots. Click on them. Negative 5 and 5. Those are what your x equals, because your x equals that first number in your point. Okay, we've looked at the graph. Now we're down here at C. Okay, here on C, I threw in something to see if you could see something. C looks exactly like our problems did at the beginning of the page. So we're going to solve for it like at the beginning of the page. Divide by 4, divide by 4. I get x squared to equal, now you're going to look and say, this one does not come out nicely. Okay, if I grab my calculator here, 81 divided by 4 is 20.25. Okay, I'm still going to put 20.25. Okay, final step, take the square root. Remember, plus minus. Square root of x squared is x. And now, square root of 20.25 is 4.5. So x equals plus or minus 4.5. Okay, and we're going to look at the graph of this one and talk about it real quickly. Okay, looking here at C, checking again our answers. 4x squared equals 81. Okay, find where it crosses, hit those gray points, and they will tell you exactly what those points are. Okay, and remember, the first number is in the parentheses. That's what your x equals, and we get the same thing, a positive and a negative 4.5. Nice thing about this is the same graph, the same type of calculator you get on any SOL. So what you're able to do here now, you're able to do on the SOL. Okay, now we're on here to D. We're almost halfway done with these. So first off, it's set equal to 0. Okay, that allows me to go through and get right into solving these. Okay, when solving these, I could look and say, there's no GCF because this is a 1, a 4, and a 3, and everything does not have an X, so I can go right into factoring. So there's 3 terms. I need to determine, does this break off into A equals 1 or A does not equal 1? Look in front of your x squared. In front of my x squared is nothing or a 1, so this is an A equals 1 problem. Okay, A equals 1. Okay, when A equals 1, identify your A is 1, my B is 4, and my C is 3. I'm going to write out factors of C. Now, since your C is positive, remember that told you either both factors are positive or both are negative. So factors of 3 are 1 and 3, or it's negative 1 and negative 3. Once you have written out your factors of C, you're looking for the ones that give you your B or add to your B value. Out of those factors, the only ones that add to 4 are 1 and 3. Now, when it was A equals 1, factoring this was pretty easy. You have your 2 parentheses. Okay, if it's normally started with x squared, so it's always x and x, your factors would go here second. Okay, since it's a positive 1, it's a plus 1. Since it's a positive 3, it was a plus 3. Now that it is factored, the next step is, remember, set each parentheses equal to 0 and solve for x. So x plus 1 equals 0. X would equal a negative 1. X plus 3 equals 0. X would equal a negative 3. There's my solutions. And again, let's look at the graph of this real quick. Okay, the next problem here at D. We're going to again write the problem. X squared plus 4x plus 3 equals 0. Okay, find where it crosses the x-axis, which remember on Desmos, they're the gray points. Hit the gray points, and they're always going to be the answers the first in your parentheses, so negative 3 and negative 1. Which is exactly what we got. The nice thing about this is it's a great checking tool. Okay, sure, we could solve all these by graphing, but if they have specifically in the directions you have to do it by factoring, we have to show the work that we've been showing, but we could always check our answer. Okay, now that we've looked at the graph, let's go down here to E. First thing, this is not set equal to 0. Notice how A, B, C, and D all had them set equal to 0, so we need to get this set equal to 0. First thing that makes this easier is just add 16 to both sides. Okay, I can't combine it with anything, so I'm just going to put that 16 at the end. So this problem really looks like x squared minus 8x plus 16 equals 0. Okay, again, there's no GCF. It looks exactly like D. So what I'm going to get into is this is the same thing as D. It's a trinomial, and A equals 1 because there's nothing in front of x squared. So A equals 1, B equals negative 8, C equals 16. I'm writing out my factors as C. Since C is positive, my factors are either both negative or both positive. Factors of 16 are 1 and 16, 2 and 8, 4 and 4. Or it could be -1, -16, -2, -8, -4, and -4. I'm looking for which ones add up to my B value of -8. And it's -4 and -4. Factoring this one, remember, was pretty simple. You have your two parentheses. Starts out always with X and X. Okay? Your factors are what go in these last two spots. Since it's a -4 is -4, -4. Set each parentheses once you factored equal to 0. So X minus 4 equals 0. X minus 4 equals 0. Solve for X. X equals 4. X equals 4. Let's look at this one on the graph to see what it looks like. Okay, back here at the next one, which is E. So I have X squared minus 8X equals a -16. You do not always have to put this equal to 0. Okay, could I have? Yeah, I could look in here and say plus 16 equals 0. I still get the same thing. This only crosses it once, which is at 4. And I could get this by scrolling out more and more. So I see this as a 4. Okay, now that we've seen this one on the graph, let's look at our last two problems. So first off, here on F, it's already set equal to 0, so I'm good to go. Okay, if I'm looking for a GCF, there is no GCF here on F, so I can go right into factoring. This one falls into the A does not equal 1 under 3 terms. Here on this problem, if I look back on F, A equals 2. So now, I'm going to write the problem here on this separate sheet of paper so we have more space to solve it. 2x squared plus 3x minus 5 equals 0. Okay, when A does not equal 1, once you check for GCF, the next step was to multiply A and C. Well, A is 2, B is 3, and C is -5. A times C would be 2 times -5, which is a -10. You're going to then go through and write the factors out of that -10. Okay, well, if I'm listing out factors of -10, okay, if it's negative, remember it's one of each. So one positive, one negative. I have 1 and 10, 2 and 5. What I do for these is the first numbers get the negative. Then when I write them again, the second numbers get the negative. I'm looking for which one gets me to B. Which one gets me to 3? -2 and 5 gets me to 3. Remember, those factors are how we're going to rewrite our middle term. Instead of this looking like 3x, it's going to look like a -2x and a positive 5x. So 2x squared minus 2x plus 5x minus 5 equals 0. Okay, I'm going to go through. Taking out a GCF out of the first two, once I have broke them up. Okay, out of 2x squared minus 2x, I have a 2x. So I'm left with x minus 1. Okay, 2x squared divided by 2x. 2 divided by 2 is 1. I had 2 x's. I took away 1. I'm left with 1. If you have to, up here at the top, I'll put the GCF there so you can see it written out. GCF out of 5x minus 5 would be a 5. Okay, I'll divide these by 5. 5 divided by 5 is 1, but I have an x. -5 divided by 5 is a -1. Great. We always look for the parentheses to be the same. They're both the same. They're both x minus 1. We did it right. X minus 1. And then from left to right, 2x. Since this was a positive 5, it's a plus 5. Once you have factored it, just like we've done on all the other problems, set the parentheses, or what we call the factors, equal to 0. X minus 1 equals 0. That would be x equals 1. 2x plus 5 equals 0. I'd have to subtract 5. That'd be 2x equals a negative 5. Divide by 2. X equals a negative 5 halves. Circle that. Circle that. Okay, you can either let this in fraction form, or you could say negative 2.5. Okay, so let's look at the graph of this one, especially since this is not a whole number. Now looking at our f, I have 2x squared plus 3x minus 5 equals 0. So here is our problem. If I zoom in here, click on the gray dots. Okay, remember again, the numbers that at the beginning of the parentheses is your solutions. Negative 2.5, which is the same as negative 5 over 2, and then a 1. We got the same answers. Great checking tool by checking this by graphing. Okay, we've looked at the graph. We're here on our last problem. So first thing on our last problem that runs into an issue is we're not set equal to 0. Okay, set equal to 0, I'm going to move the 15 to the other side by adding 15. I get 3x squared plus 14x plus 15 equals 0. Okay, there is no GCF. 3, 14, and 15 only have a 1 in common, and not all of them have an x. So this is just like f. Your first term is not 1. So just like the last problem, I'm going to bring out another piece of paper just so we have enough space to do this problem. So I rewrote the problem of 3x squared plus 14x plus 15 equals 0. No GCF, so I can go right to this first step. Identify A, B, and C. A is what's in front of x squared, which is 3. B is what's in front of x, which is 14. C is your constant, your number at the end, which is 15. First rule says multiply A times C. 3 times 15 is 45. That's the factors I want to list out. Since my A times C, which creates my new, in quote, C, I'm listing out those factors, and since it is positive, both factors are positive or both factors are negative. So 1 and 45, 3 and 15, 5 and 9. Now, I'm going to write them both negative. Negative 1, negative 45. Negative 3, negative 15. Negative 5, negative 9. Okay, now I'm looking for which set of factors get me to my B. Which set of factors get me to 14? 5 and 9. I'm going to take that 5 and 9 and I'm going to split this 14x into a 5x and a 9x. So 3x squared plus 5x plus 9x plus 15. Put your first two in parentheses, your last two in parentheses. Your GCF out of 3x squared plus 5x is just an x. So I'm going to divide these all by an x. 3x squared divided by x is just x, plus x divided by x, you have none left, so it's 3x plus 5. Out of 9x plus 15, your GCF is a 3. You only have a GCF with a number, not with a variable, because they don't have it in common. So divide this all by a 3. 9 divided by 3 is 3. I attach the x. Plus 15 divided by 3 is a 5. Huh. 3x plus 5 in both parentheses, so I'm good to go. Write what is in both parentheses that is the same, and then write left to right what we took out, x, and since this was a positive 3, it's a plus 3. Once you have factored it, set each parentheses equal to 0. 3x plus 5 equals 0. X plus 3 equals 0. I'm going to start with the easy one. X plus 3 equals 0. X would equal negative 3. I'm going to subtract 5 on both sides. I get 3x equal negative 5. And then divide it by 3. I get x equal a negative 5 over 3. Or you could put it in decimal form. It's up to you. I'm going to go back here to the original problem and just put x equals negative 3. X equals negative 5 thirds. Okay, and just like we did on that last problem, let's go to the graph. Okay, our last problem, 3x squared plus 14x plus 15, we'll do that. Okay, and I could say equals the 0. Okay, and what I notice is if I click the dots, I get negative 3 and negative 1.667, which is negative 5 over 3. Okay, like I said, graphing is really important. You have this available to you. Please use it as a checking tool. Okay, now that we've looked at all the graphs, we are done with this solving quadratics with graphing and also with factoring. When we see each other in class next, we're going to continue to practice this. I hope everyone is having a great lesson, is having a great day. And if you have any questions, don't forget to ask them. And I will see you back here next class. See you later.